Okay, lines page 5, number 6. Line L1 passes through the point 0, 3 and negative 2, comma a. Find an expression for the gradient L1 in terms of a. Okay, now they're really forcing you to use this equation here. So let's write this again. We'll write our little table. 0, comma 3, negative 2a. This is point 1, this is point 2. So we're going to say, okay, y2a minus y1, 3, divided by y2, or x2 minus 2, minus x1a. Okay? And so that gives us a minus 3 divided by negative 2. And so that's the expression that they want. Okay? The gradient in terms of a. L1 is perpendicular to L2. The gradient of L2 is 2. So the gradient of L2 is 2. So that means that the gradient of L1 would be negative 1 over 2. It's a negative reciprocal. Now find the value of a. Okay, so now we know that a minus 3 divided by negative 2 is also equal to negative 1/2. So we can cancel those out, we can cancel that out, and we get a minus 3 equals 1. So a is equal to 4. We add 3 to both sides, right? Number 7. Find the points, or the points a, 3, 5, and b, 5, negative 8, lie on the line L1. Find the gradient of L1. So we could do this many number of ways. I drew this here because I thought it would be easier if you graph this one. 4, 5, 3, 5. 5, negative 8 would be 5, and then 1, 2, 3, 4. 1, 2, 3, 4. It would be about here. Okay, so we would have a line about like that. Find the gradient of L1. Okay, so how do we want to do this? Do you want to try it on the calculator? Stat, edit. I'm going to put the two numbers here, which are 3, 5, and 5, negative 8. Negative 8. Okay, and then I do stat, calc, linreg, L1, L2. I go to the calculate. Okay, and so the gradient of this blue line is negative 6.5. Negative 6.5. And I could have found it other ways. I could have used the formula, could have counted blocks. A second line, L2, is perpendicular to L1. Write down the gradient of L2. Well, so B, what they're saying is, okay, there's a perpendicular gradient, and it's equal to negative reciprocal of m, so it would be negative 1 over negative 6.5, so that would be the same as 1 over 6.5, right? Then they say that, hey, L2 actually goes through these 2 points, 5, 0 and t, 2. What's the value of t? Okay, so now we could write down the 2 points here. So we have 5, 0 and t, 2. What's the slope of these 2 points? y2 minus y1 divided by x2 minus x1. And we set that equal to 1 over 6.5, which is equal to 2 divided by t minus 5. So t minus 5 equals 2 times 6.5. So t minus 5 equals 13. T equals 18. Okay, so let's see. Let's graph that. So one of our points is 5, 0, and the other points is like 18, 2. Okay, so yeah, that looks like it might be perpendicular. Okay. 3E, number 1. Find the equation of a line with gradient 3 that passes through the point 1, 4. 1, 4 is there. Gradient 3, so that would be like that, right? So the point that it goes through here on the y-axis would be 1 comma 0, or 0 comma 1. Okay, and we can use that. We can use that to already find the gradient intercept form, because we know the gradient intercept form looks like this: y equals mx plus c, right? And we know that the y-intercept is c, so the y-intercept is 1, and we know that the m is 3 because they said the gradient is 3, and there we go. Okay, so A was quite easy. What about B? Gradient 5/3 that passes through the point 4 comma 8. So 4 comma 8 would be here. And then I'm just going to show you like these by graphing, because so a lot of these you can do by graphing. So 4 comma 8, and then the slope is 5, rise 5, and run 3. So let's see how that looks. Rise 5, run 3. So rise 5, run 3. Okay, and then rise 5, run 3. So here. That also looks like it might go through 0 comma 1. I'm not sure though. My drawing is like not that good. Okay, it probably doesn't. Okay, but another way you could do this is we do know for sure that it goes through 4 comma 8, and oh, you know what? Yeah, it goes through 4 comma 8, and what's that point there? We're pretty sure about that point. Instead of 4 comma 8, it'd be 1 comma 3. Okay, so we have 2 points. We have 1 comma 3, and we have 4 comma 8, and we know that the line goes through both of those. So now we can use a calculator and linreg, and we can calculate that. So we can put 1 comma 3 and 4 comma 8 in here, and we'll do linreg, and then it'll give us the equation for the line. So stat calc linreg L1, L2, frequency less is nothing, and it gives us the equation for the line here. So for B, it would be y equals 1.66 repeating x plus 1.33, and remember that this is the y-intercept. So remember I said it looks like it's 0 comma 1, but it probably isn't. Yeah, it wasn't in the end. Okay, so that's for B. Now what about C? C asks for the gradient of -2 that passes through -3 comma 0. So -3 comma 0 is here. And then they said the gradient of -2. So -2 would be rise -2, run 1. So it would be kind of like that. So it hits the y-axis there, which is at -6. So we could write it already. We could say y equals, and C would be -6 because that's here where it hits the y-axis, and the gradient is -2, so we put -2x and then -6. Okay, so that would be C. All right, moving on to the last one. Just a note here, a hint about the calculator. So x-intercept is when y equals 0, and can be found with the GDC by doing second calc 0. Okay, so whenever they ask you for the y-intercept and you have the equation for the line, it's pretty easy to find. Okay, all right, now they give us 4 equations here, and the first thing they want you to do is find the gradient. And to find the gradient is pretty easy because these are all in gradient intercept form, which, remember, that means that m, which is the coefficient multiplied times x, is the gradient. So the gradient is there, 2, it's there, -3, it's -1, okay, and -2/5, okay? So we've already found the gradients for all. Point of intersection with the y-axis. Okay, remember the point of intersection with the y-axis happens to be this c value here. So there, and -1. So we're done with that. See how useful the gradient-intercept form is? You can get a lot of information just from looking at it without doing anything. Now, the point of intersection with the x-axis is not so easy. The way you would do that with algebra is you would say, hey, when is y equal to 0? So you set the y equal to 0, and then you solve for x. So like, you would do algebra here, you'd subtract 1 from both sides, you get negative 1 equals 2x, so x is equal to negative 1/2, right? Which is, possible, but maybe if you're weak in algebra, it's kind of hard. So let's do the next 3 with the calculator. The way we do that is we program the function negative 3x plus 2 into the calculator. So negative 3x plus 2, we put it in the calculator, and then we're going to graph it. And now we're going to see, okay, when does it intersect the x-axis? The way we do that is we use the second calc 0 function. That tells you when does y equal 0. And you just need to say, okay, I'm going to do this function. The left boundary of the intersection is right there, you can see. So left boundary there is fine. I'm a little bit to the left. Now I'm going to go a little bit to the right. Oops, I didn't have it. I have to hit enter. Okay, yeah, sure. That's the left boundary right there. It puts a triangle there. Then I go a little bit to the right. A little bit to the right of the intersection with the x-axis. And then I hit enter. And is that my guess? Sure. And so then it finds the 0 point. So it says x is 0.6667. Obviously it's 2/3. And y equals 0. Okay, so for this one, x is equal to 2/3. Or you could put 0.666 or whatever. Now we'll do another one. Okay, so instead of negative 3x plus 2, it's negative x plus 3. So negative x plus 3 graph, and then we're going to see when it crosses the x-axis. So we go second calc 0, left bound here, then we go a little bit to the right, right bound, guess, okay, 3 comma 0. So x is equal to 3. Next one. We just program in negative 2/5, negative 2/5 x minus 1 graph. And then we're going to see where it crosses the x-axis using second calc 0 function. Go a little bit to the left of the intersection with the x-axis. And then we go a little bit to the right. What happens if you don't do this properly? It doesn't find anything because there has to be an intersection between the 2 points you give it. Otherwise, it'll just say it's confused. Negative 2.5. Okay? And that's it for this page.